Hello and welcome to my Genetics 311 Module 2 exam video. Today we're going to be talking about gene mapping and we're going to use an alien genetics map for our example. So we have three traits we're going to talk about today: the number of eyes, the color that they are, and spots that they have or don't have. So 3 eyes is dominant, blue skin is dominant, and no spots are dominant traits for our example. So our goal today is going to be find the probability of different phenotypes that are caused by distinct crossover events. So how can we do this? We are going to cross two peer breeding aliens. So one will be peer breeding dominant traits and one will be peer breeding with recessive traits and alleles. So when they have a kid together, that kid will be guaranteed to be a heterozygous dominant in all three of these traits. So he will have one of the dominant allele and one of the recessive. So after doing a little bit of research, we found out our map. So we're going to be using this later on for some of our calculations. So what we're going to do is we're going to test cross our F1, which is our heterozygous one. We're going to test cross him with a homozygous recessive alien. So when those have children together, we're going to be able to see, based on the ratios that their children have in different phenotypes, if independent assortment is occurring or not. So possibilities of their children are going to be very broad. They have 8 different possibilities, and they depend on the different events that occur. So there's a double crossover, no crossover, single crossover, or single crossover in the first position, or single crossover in the second position. So now we're going to try to find some of these phenotypes and probabilities for those. So we're going to start off with a double crossover probability calculation. So what we're going to have is some of these equations here. I just wrote them down ahead of time. And our goal is going to be to calculate the probability of progeny with 3 eyes, green skin, and no spots. So 3 eyes, green skin, and no spots. So what we're going to try to do here is we're going to get some of our data. So we have our R1 data that comes right from here. So that goes to 0.12. Our R2 data is 0.17, and our coefficient is given to us. So all we're going to do is plug these into the formula, and we have to remember that we are using the specific gamete formula. So we're going to be using this 0.5 added on the front because half of these double crossovers will not give us what we're looking for. So once we plug those in with this formula, they're color-coded in case you want to see where each number is coming from, we get a 0.765% chance of the time that we would see this occur. So next we're going to move on to a single crossover probability calculation. So this time we are going to be trying to calculate a 2 eyes, blue skin, and no spots. So we have 2 eyes, blue skin, no spots. That's a single crossover in the first. And so our formula for this one is going to be, once again, we're looking for that specific gamete. So we're going to have 0.5 times our R1 minus our double crossover, because we only want one crossover in this case. So we're going to plug that into our formula right here, and we're going to multiply it times 0.5, and we're going to get 5.23% of the time we would see this exact progeny. So after that, we have the progeny of all of the possibilities, and I have 2 columns. So one column is just the probability of the type of cross that could occur, so the probability of that, also with the probability of a specific gamete. So these are some of my references, and thank you guys for watching.